In this lecture, we are going to study about non-radiative transitions and the processes that are involved in non-radiative transitions, that is, Auger recombination, surface recombination, and recombination at defects. This is lecture 2 of Unit 3 Optoelectronics. Now, what is non-radiative transitions? First of all, we got to understand that when energy is given to a system, the atoms will go from lower energy states to the higher energy states. From there, when they come down from the higher energy states to the lower energy state, may give out light or they may not give out light. If they give out light in the form of photons, they are called as radiative transitions. But if they come down from the higher energy states to the lower energy state, without giving out light but giving out heat, then it is called as non-radiative transitions. Therefore, non-radiative recombination occurs when an electron in conduction band recombines with a hole in the valence band and the excess energy is given out as heat. Non-radiative recombination processes involve Auger recombination, surface recombination, and recombination at defects. So what is Auger recombination? One electron from conduction band recombines with a hole in the valence band and releases energy. This energy may be taken by another electron in the conduction band. These are all free electrons. Okay? The electron that gained energy jumps to a higher state and then comes back to the valence band by giving out its energy. So in this case, the energy is transferred to another free electron in the conduction band. What is another case? One electron from conduction band recombines with a hole in the valence band and releases energy. This energy may knock out an electron and create a hole. This hole is created in the valence band. Both the processes are non-radiative, that is, they do not give out light but they give out heat. Now, what is surface recombination and recombination at defects? Recombination at surfaces and interfaces. Interface is a area where one type of material meets another type of material, or where the termination of one type of material. So recombination at surfaces and interfaces can have a significant impact on the behavior of semiconductor devices. This is because surfaces and interfaces typically contain a large number of recombination centers because of the abrupt termination of the semiconductor crystal, which leaves a large number of electrically active states. In addition, the surfaces and interfaces are more likely to contain impurities since they are exposed to during the device fabrication process. So in all this we have seen in the previous lecture and this lecture transitions which could be radiative and transition that could be non-radiative, and all this occurs between the conduction band and the valence band. We should remember that in the valence band electrons are bound electrons, whereas in the conduction band the electrons are free electrons.